Let's talk about on how to design the program to power on and power off our amplifier, and how to control our digital Class D power amplifier, especially the TDA8920 BT8s, and using the mute and the standby controls so that we can use its power management features. In episode 8, we will going to see the sequence of activities of our MMI hardware, the LCD, the LED, the buzzer, the backlight, and the switch S9, which is served as our power on off switch. We will take a look at also the mute controls and also the standby control of our digital Class D amplifier, and we can see that actually in the timing diagram. And guys, if you are new to my channel, you may consider to subscribe, as your subscription will help me to grow my channel and keep me here at YouTube posting DIY amplifier stuff, pre-tutorials, and of course keep me alive here at YouTube. Hi, my name is Ferdinand and my friends call me Dandy. I'm a raw DIYer in electronics, designing my own circuit, writing my own programs, and building electronics projects. I love my hobby. It's a powerful source of personal achievements, happiness, and self-fulfillment. And here is a series of videos I created, so go on, keep watching, and learn about this project. Thank you for watching. Let's take a look at the sample program, which is based on my understanding of the timing diagram and how the LED, the buzzer, the backlight, the LCD, and the switch, how the user depress the switch S9, which is the power on off key, to start the event-driven activities. And we can see the program listing in program 10, where we can see similar instruction for the MMI hardware. It's just to use them based on the sequence of activities as depicted in the timing diagram. Let's see the timing diagram, and the first hardware is the LED with the logic level characteristic. We have logic 1 initially after the reset by the micro, which means that the LED is turned off. Then we have a series of logic 1 and 0, which indicates that the LED is actually blinking. Then keep the LED turned on. So let's see, and let me jump into the real world output as depicted by this timing diagram characteristic. Here come next is the buzzer, where again after the reset by the micro, it beeps to tell the user that hey, wake up. The next hardware is the backlight, wherein it initially turned off after reset, since the 8051 micro port will initially at logic 1. Then it turned on by the instruction, so the display can be seen on the LCD during the initial display, or sometimes I call that as a preamble display before the real standby mode. That is the real standby mode display. And then somewhere in the standby mode, the backlight logic turned into logic 1, which means it turned off the backlight. This is so because it will going to reduce the current consumption from about 56 milliampere down to 27 milliampere with the only LED is lighted. The LCD basically follows the MMI for the backlight. That's logical since it's hard to read on the LCD if there is no backlight. Makes sense, guys? So let's see, and let me jump into the real world output as depicted by this timing diagram characteristic. Let's see that. Let's see the mute control in digital amplifier like the TDA8920 BDH, wherein it will disconnect the speaker output, which is an internal action inside the chipset, so that the noise on the speaker like a thumb, sometimes a tick, or an oscillation will not be heard during the power on, that is the active mode, and during the power off, that is the standby mode. The other control is the standby mode, which will put our digital Class D amplifier, again the TDA8920 BTH from NXP Philips, to reduce its power consumption when it is not in use or in the sleep mode, so that the electrical power will not be wasted. And our project, the DR 100 watt concept, will be compliant to the eco mode or the economy mode, which requires that the power consumption must be less than 1 watt in the sleep mode. To implement the mute and the standby mode in reference to the TDA8920 BTH, the Class D amplifier we use in our project, you need to deep dive on the datasheet specification, probably on page 22, on the external transistor switch, and understand about the standby, mute, and the operation voltage. And unfortunately, we will not be covering on episode 8 as we are in the programming, as the real-world power consumption of the digital Class D amplifier has been performed in episode 2 of discovering the Class D power amplifier and test item number 5, that is the power management, the power consumption in the sleep mode. That is starting from video 4.25 minutes. But sorry guys, the video voice and presentation was those when I was just starting YouTube, and I'm a little bit shy to speak on my Motorola phone. I hope you can spare me for that. Let me know in the comment below on how to improve further on the viewpoint of the beginners or starters. Well guys, I gave emphasis on the power management since one of the features of the DR 100 watt concept project is the programmable timer to auto turn off the amplifier to save the power when not in use. You know, I love to play my music at bedtime, and somewhere it needs to auto turn off when I'm already sleeping. We are DIYers and we customize the features we want to implement in our project, something special that makes our hobby a self-fulfilling masterpiece. I mean, you know what I mean. Something that makes you really happy, you know. Well guys, it's the end of my video. Thank you for watching and see you in the next video. Don't forget to subscribe. Bye for now.